Okay, so one conclusion we can draw, and we got a good answer to this, is that this thing has zeros. When x equals -3, it's going to be 0. When x equals -2, it's going to be 0, right? And it's easy to find the zeros once you have it in this form. You just take whatever this is and set it equal to 0. Solve that. It tells you an x value that makes it 0. Now, you don't have to write out an equation and solve this one, but you know, if it was 17x plus 48 or pi x plus e, okay, you'd have to solve an equation. And in the latter case, you would get an exact answer, but you'd get a good approximation. Okay, so I can set this equal to 0 and solve it for x, can I? I can set this equal to 0 and solve it for x. And no matter what linear factor I have, it's just a linear expression, something times x plus something. I set that equal to 0, take the second something, change its sign, move it over to the other side, divide by whatever's in front of x, and I've got it, right? Easiest thing in the world. Okay? So, so we see that because of this, y is 0 if x is 3, and y is 0 if x is -2. This is never 0 since it's irreducible. If x isn't -3 or -2, then none of these is 0. Okay? Only way this is 0 is if x is -3. So if it isn't one of these, it isn't -3, so it's not 0. Similarly, if x isn't one of these two, this one isn't 0. And this is never 0. Now if you got three numbers and they multiply out, and none of them are 0, when you multiply them together, can you get 0? Everybody give me an example of three numbers that you'd multiply together and give you 0? Is it possible?
Multiply
No.
by 0.
Huh?
You multiply by 0.
I said none of the numbers is 0.
Oh, well, no.
I give you three numbers, none of them is 0. It's not possible to multiply any string of non-zero numbers and get 0. Okay? Like take the first two numbers. This isn't 0, this isn't 0. You know you're not going to get 0, right? And then take the third number and multiply that by what you got for the first two. You know, your first two didn't multiply out to 0. The third one isn't 0, so now you've multiplied two non-zero numbers. Now you know your first three numbers don't multiply out to 0. And you do that one number at a time until you're done. You can't get 0, okay? Unless one of your numbers is 0. So the graph passes through the y-axis. Through the x-axis, sorry. When x equals -3 or x equals -2, and for no other values of x. Make sense? It should, and if you don't understand it, well, you gotta do a lot better if you do. So, do whatever is necessary to try to understand it. If you don't understand why, though, you just can't get yourself to understand why or don't have time to delve that deeply, just know that's the rule. But there's a straightforward reason to. Okay? Now again, not everybody has done enough arithmetic without punching it into a calculator to understand how numbers work very well. And it might be, you might find some of this reasoning a little unfamiliar. It's not that hard, so try to get it. So now, if we draw the x-axis, we can label these points as points that are on the graph, right? And the rest of the graph, any other point on the graph either lies above the x-axis or below, because if it lies on the x-axis, that would be a 0, right? And it can't be. Okay? So, the graph goes through the x-axis at these points, or maybe touches the x-axis, like, for example, y equals x squared has a 0 when x equals 0, right? That gives you your parabola that just touches the x-axis at 0, but it doesn't go through, right? Okay? So it's possible that a polynomial could touch the axis without going through it. Okay? On the other hand, x cubed goes through 0, right? Okay? And so does y equals x, a linear function will go through the x-axis at exactly one point. Okay? So your polynomial can do that. It could go through the x-axis either this way or this way, and pretty much along a straight line if you look close enough. Okay? But it's not going to stay on a straight line. The polynomial is going to curve at every point. Okay? It's not really going to be a straight line, but if you look closely, any curve, if you get close enough to it, looks like a straight line. We're close enough to the earth to make it look flat, right? Not so much here because all the mountains and stuff, but you understand what I mean. If you're out in the ocean, it looks flat. Get up high enough, you might be able to start. You notice that things go over the horizon, but if you go there, you don't fall off. So you draw conclusions, right? Okay? Look close enough at any curve, and it's going to look straight, even if it's a curve. It's possible you hit the axis like this and just touch it at the point without going through. It's possible that you come down like this and level off and just almost level off and finally go through right at this point and then start going down again. So you go through the graph only at that point, but it's going to look like this, just like the x cubed function does near 0. Okay? So those are the three basic behaviors. You can have higher powers and stuff. We'll worry about that later. Okay. So, but you have to understand the power functions to understand what the graph looks like at those points. It's going to go through these points, and close to the point, it's going to behave like one of your power functions. And you got to know what the power function looks like. Okay, well, I'm going to assume you do. Okay, there's something else. The graph is continuous, meaning that it doesn't have any breaks in it. It doesn't go along like this and all of a sudden jump up here instantly. It's nice and smooth and continuous, and it's curved smoothly. Okay? Not going to prove that, although I could. And a lot of you would understand it, but that goes a little further than we need. So you just have to understand that the graph of a polynomial function doesn't have any breaks in it, and it goes all the way from negative infinity to infinity. Okay? And usually, I mean always, it gets really, really high or really, really low pretty fast. But it's still defined all the way from negative x equals negative infinity to infinity. There's no number that I couldn't put in here and get a result, right? It might be really big. like if I put 1,000 in here, well, this is going to be at least 1,000, this is going to be at least 1,000, this is going to be at least 1,000 squared, meaning that this number is going to be at least 1 trillion. Okay? So 1,000 isn't that big. You can imagine 1,000 trillion, forget it. Okay? We'll get to that. Okay, so one of the big things I got to tell you though is that it follows that since the graph doesn't have any breaks in it, that, for example, between -3 and -2, it isn't hard to figure out that this thing has to be negative. Okay? I'll tell you how, and many of you will understand it. Some of you, I'm going to say it kind of fast. So if you don't understand it, don't worry, but you might want to go back and look at the video. If x is between -2 and -3, then is x plus 3 positive or is it negative? X is between -2 and -3. I'm going to add 3 to it. Do I get a positive number or a negative number?
Positive.
Yeah, I'm going to get a positive number. Now, if x is between -2 and -3 and I add 2 to it, what do I get? It's got to be negative. Okay? -2 added to anything that's less than 2 is going to be negative, right? And then this might be positive or it might be negative, but you can easily determine that it's going to be positive. Okay? Yeah, I won't go into detail. Just saying there's an easy way to reason out that this thing has to be negative all the way from -3 to -2. Okay? So I can write this. I can write, okay, I can kind of write negative. I know that this function is negative here. Okay? In fact, all I have to do is pick a number between -3 and -2. The graph can't go through the x-axis between -3 and -2, so either it's below or above for the whole interval, right? Because if it was above somewhere and below somewhere else, it would have to go through the x-axis, and we just showed that it can't. Okay? So I could take -2.5. Now we can do this. We can plug -2.5 in for x plus 3. We would get what? If x is -2.5, what's x plus 3? It's a half. What's x plus 2 if x is -2.5? You do -2.5 plus 2, you get -0.5. So I know I've got -1/4 here, right? Okay? And then I could square 2.5, which would give me 6.25. 5 times -2.5 be -12.5. But then I'm going to add 12. So this is going to be, positive. Okay? So I've established that there's a number between -3 and -2 that makes this thing negative. Okay? And it can't be 0 anywhere in between here. And it's nice and smooth and continuous, so it can't go through the x-axis anywhere between here and here. So it's got to stay on the same side. Since it's negative at -2.5, it's got to be negative for the whole interval. So now I know that the graph looks kind of like this between -3 and -2. Okay? Then, what's a number to the right of -2 that would be really easy to plug in here? Easier.
0.
0. Okay? Wherever 0 is, use it if you can. Okay? I plug in 0, I get 3 times 2 times 12. Is that positive or negative? Again, is 3 times 2 times 12 a positive number or a negative number? I'll give you a hint. All three of those numbers are positive. Yeah, it's positive. Okay? Okay. So I know so all the way from -2 to infinity, the function is positive. Now see, when I drew this, I probably should have drawn it the other way. If I have my -3 here and my -2 here, it could have done this and still had zeros at -2 and -3, right? Or it could have done this. Or it could have done this, and we still don't know that it didn't do this. Okay? Okay, so what's a number to the left of -3 that you'd like to plug in? Probably -4. You don't want the numbers to get too big. You don't want to use fractions or decimals. If x is -4, you can plug that in. You get -1 and -2, right? Now, this is always positive since it's never zero, and you know it's positive one place, it's positive everywhere. So you know that you have a negative times a negative, it's going to be positive, so it's positive here too. Now, you probably can't read that. It says it's positive at x equals -4, so it's positive to the left of x equals -3. So again, it's positive from here on. So positive here, negative here. What's a graph look like? Well, it's a parabola, kind of like a parabola, not exactly a parabola, but it sort of has the shape of a parabola, okay? The vertex is not halfway between the zeros, as it would be if you didn't have this thing, right? But this thing makes that vertex go somewhere else in a way that's easy enough to understand, but I don't want to strain you any more than an hour and a half.